Hello again, welcome to another video lesson. We're looking at multiple angle identities, specifically our half angle identities. And after this video, we'll be able to use our half angle identities to solve trigonometric equations, look at expressions, and all that good stuff. So let's hop into it. Okay, our half angle identities, they're derived from our power reducing identities. Okay, power reducing identities. And all we're doing here is we're replacing theta with theta over 2. Okay, so let's take a look at one of our power reducing identities. We have sine squared theta is equal to 1 minus cosine 2 theta over 2. Okay, so what we're going to do here, okay, in order to reduce the power here, I'm going to have to take the square root, right? Take the square root of both sides. And when we do that, we get a plus and minus on this side, but our square and our square root cancel out for sine. Okay. And let's see, we'll go ahead and, at this point, we'll replace theta with theta divided by 2, okay? It's going to be equal to plus or minus square root of 1 minus cosine of 2 theta divided by 2 all over 2. And we can see here that our 2's cancel out, and I'm left with sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. Okay, so that is the proof of one of the identities. I'll go ahead and put the other two up here. Okay, now something to keep in mind, we have this plus or minus, but often we do only want to use one at a time. Okay, so we want to determine the sign that we're going to use by checking the quadrant of pi over 2. Sorry, not pi over 2, but theta over 2. Okay, so check the quadrant of theta over 2 to determine the sign to use as far as our plus or minus goes here in front of our square root. Okay, all right, let's take a look at our first example. Okay, we're going to find the exact value of the sine of 75 degrees. Now, sine of 75 degrees is not a point on our unit circle that we know, right? Okay, but we do know the sine of, say, 150 degrees, right? So we're going to rewrite this as the sine of 150 degrees divided by 2, okay? Because we know 150 on our unit circle, okay? Okay, so now let's think. What quadrant would we be in at 150? 150 is something like this, right? So we're in quadrant 2 here. We're in quadrant 2. So we're going to keep that in mind when we're working with our sine, right? When I have my sine for my square root for my radical, okay, the sine is my y value here, okay, so this is going to be positive in quadrant 2, so I'm going to have positive square root here. Okay, it's going to be equal to 1 minus cosine of 150 degrees all over 2, okay. Cosine of 150 is negative root 3 over 2, so this is going to be equal to square root of 1 minus negative root 3 over 2 all over 2. Okay, and then if I were to make my 1 2 over 2, so we can combine these in the top, that's going to be 2 plus root 3 over 2 all divided by 2, and that's under my square root there. Okay. Okay, so this is going to look something like 2 plus root 3 over, okay, I've got 2 times 2, so it's going to be 4, so square root of 4 is just 2, and that is what my final exact value would look like, okay? Okay, let's take a look at another example, okay? We're asked to solve 2 sine squared x divided by 2 plus cosine x is equal to 1 plus sine of x on the interval 0 to 2 pi. Okay, so we're going to use our half angle ID here. We're going to use sine of theta over 2 is equal to plus or minus 1 minus cosine theta over 2. Okay, I'm going to replace this here with my radical. Okay, I've got 2 square root of 1 minus cosine theta over 2. Okay, now this is squared, right? This is squared, so it doesn't matter what sign I use because I'm actually going to square it, and my radical is going to go away. Okay? Plus cosine x is equal to 1 plus sine of x. Okay? And then my 2's are going to cancel out here. I'm left with cosine x is equal to, 1 minus cosine x plus cosine x is equal to 1 plus sine of x. Okay, so I got positive and negative cosine x, so those will cancel out. I got 1 on each side of my equation, that'll cancel out. So I'm left with sine of x is equal to 0. Okay, so if I go ahead, I'm asked to solve, so let's take the inverse sine of both sides. Inverse sine. Okay, and x is going to be equal to the inverse sine of 0. Inverse sine of 0. Okay, on the interval, don't forget the interval, 0 to 2 pi. Okay, so where do we have a sine, or what angle gives us a sine of 0? That's going to be at 0, it's going to be at pi, and it's going to be at 2 pi. Okay, so that would be our solution for that one. Okay, that's all I had for this video. Good luck with your practice.